Hello and welcome to our lecture on exceptions, arrays, and GUI programming. Let's dive into exceptions and the try-catch mechanism. Understanding how to handle exceptions properly is crucial because it helps us create more robust and error-resilient programs. Let's start by defining what an exception is and why it's important to handle them. What is an exception? An exception in Java is an event that occurs during the execution of a program that disrupts the normal flow of instructions. Think of it as an unexpected event. For instance, if your program tries to divide a number by 0 or attempts to access an array element outside its bounds, Java will throw an exception. There are two main types of exceptions: checked exceptions. These must be either caught or declared in the method. They are checked at compile time, meaning the Java compiler ensures that you've handled them. Examples include I/O exceptions or SQL exceptions. And then unchecked exceptions. These are not checked at compile time, and you're not required to handle them explicitly. They occur due to programming errors such as arithmetic exception, null pointer exception, or array index out of bounds exception. Some common causes are invalid user input, hardware failure, loss of network connection, and division by 0. To handle exceptions, we use a try-catch block. This block allows us to try a piece of code that might throw an exception and catch that exception if it occurs. Inside the try block, you write the code that might throw an exception. If an exception occurs, Java will stop the execution of the try block and jump to the corresponding catch block where you can handle the exception. You can see an example here on the screen. We're going to try to divide by 0, and we catch the error here, and we print out a message telling the user we cannot divide by 0. Sometimes a try block might throw different types of exceptions. In such cases, we can use multiple catch blocks to handle each exception type separately. In this code, if an array index out of bounds exception occurs, it will be caught by the first catch block. The last catch block with the general exception type will catch any other exceptions not specifically handled earlier. It's important to remember that the order of catch blocks matters. More specific exceptions should be caught before more general ones. After catching an exception, there's often some cleanup code you want to run, regardless of whether an exception occurred. That's where the finally block comes in. The finally block will always execute after the try and catch blocks, even if an exception wasn't thrown or if one was caught. In this case, the message "this will also be executed" is printed whether or not an exception occurs. The finally block is commonly used for cleanup tasks, such as closing files or releasing resources. Sometimes you might want to manually throw an exception in your code. You can do this using the throw keyword. This is often used in methods to signal that something has gone wrong. This is a powerful tool in Java that allows you to signal errors in your program's execution intentionally. Understanding when and how to throw exceptions is crucial for creating robust and error-resilient applications. To throw an exception in Java means to explicitly create an exception object and pass it to the runtime system. This is usually done when you want to signal that something has gone wrong in your method or class, and you want the caller of that method to be aware of the problem. When you throw an exception, the normal flow of the program is interrupted, and control is passed to the nearest catch block that can handle that particular type of exception. If no catch block is found, the program will terminate. Next, we're going to dive into one of the most fundamental concepts in programming, arrays. Understanding arrays is crucial because they allow us to work with collections of data efficiently. Whether you're handling a list of numbers, a series of text strings, or objects, arrays provide a simple and effective way to organize and manipulate these data sets. An array in Java is a data structure that allows you to store multiple values of the same type in a single variable. Think of it as a list of items where each item is of the same type and is stored in a specific order. For example, imagine you have the scores from a series of tests and you want to store them together. Instead of creating separate variables for each score, you can store all of them in an array. In this example, you can see we are declaring an array called numbers, and then we are initialing the array with the numbers 1, 2, 3, 4, and 5. Here we first create an array of length 5, and then individually assign values to each element. The elements are accessed using an index, which starts from 0. So score 0 refers to the first element, score 1 to the second, and so on. So this is an example of how you would access specific elements in an array. To work with arrays, you need to understand how to access and modify their elements. In Java, you access an element of an array using its index. Remember, array indices in Java are zero-based, so the first element is at index 0, the second at index 1, and so on. In this example, you can see we're creating an array called numbers, and then we want to output at the index of 0 for the array numbers, so we would output 10. The second example is a for loop. This will print out every element within the array. Here are some common array operations. First, we have finding the length of an array. So every array has a length property that tells you the number of elements it can hold. Next is an example of copying an array, and you can copy an array using methods like system.arrayCopy or the arrays.copyOf method, which is shown in this example. Next, you can see we have an example of looping through an array using .length. And then finally, we have an example of how to sort an array using arrays.sort and then passing the array name in. Java also supports multi-dimensional arrays, which are arrays of arrays. These are useful for representing data in a grid or matrix format, like a chessboard or a table of numbers. For example, to create a 2D array, a matrix, you might write int matrix equals new int, and then in brackets 3 and 3. That would be a 3 by 3 matrix. In this example, you can see we're creating a matrix of 0 and 1. So here we declare the matrix, and then we initialize the matrix by storing the values, and then we can access it by creating a variable and then saying exactly which element in the first row and the second column. Finally, we're stepping into the world of graphical user interfaces, or GUI programming. Up until now, most of our programs have been console-based, meaning they interact with the users through text input and output in the command line. While this is a great way to learn programming fundamentals, modern applications often require a more intuitive and visually appealing interface. That's where GUI programming comes in. GUI programming is essential for creating user-friendly applications, and here are a few reasons why learning GUI programming is important. It improves the user experience because GUIs allow users to interact with software more naturally, using visual elements like buttons, menus, and forms. Many desktop applications, from simple calculators to complex design tools, are built using GUIs. And learning GUI programming broadens your skill set, enabling you to create more sophisticated and interactive programs. Imagine writing a program that helps users calculate something, but instead of typing everything in a console, they can just click buttons and see the results immediately. Java provides two main frameworks for building GUIs. Swing. Swing is a mature and widely used GUI framework in Java. It provides a comprehensive set of components like buttons, text fields, tables, and more. And Swing is built on top of the older Abstract Window Toolkit, or AWT, and offers a more flexible and powerful API. Java FX is a newer GUI toolkit designed to replace Swing. It offers modern UI controls and supports rich media, including 2D and 3D graphics, audio, and video. Java FX applications are more suitable for modern desktop applications, but Swing is still widely used and fully supported. To get started with Swing, let's look at some basic components you'll work with. First, JFrame. This is the main window or the base container where all your other components like buttons and text fields will be added. A JFrame represents a window with a title, border, and buttons to minimize, maximize, or close the window. JButtons are buttons that users can click to perform an action. JLabels, which are used to display a line of text or an image, and JText fields, which allow users to enter text data. An essential part of GUI programming is event handling. This involves writing code that responds to user actions such as clicking a button, entering text, or closing a window. In Java, event handling is typically done using listeners. A listener is an object that waits for an event to occur and then executes the corresponding code. For example, to handle a button click, you attach an action listener to the button, like in this example. In Swing, layout managers are crucial for organizing your components within a container. Some commonly used layout managers include Flow Layout, which arranges components in a left to right flow, similar to text in a paragraph. It's the simplest layout manager. Border Layout, which divides the container into 5 regions, north, south, east, west, and center. Components added to these regions take up all available space. And Grid Layout. This organizes components in a grid with a specified number of rows and columns. Each layout manager has its own strengths and is suited for different types of UI designs, so choosing the right layout manager is key to creating a well-organized GUI. Now let's go through some examples. Our first example is going to be working with try catch. Okay, so in this example, we try to divide numerator by denominator, which is 0. This would normally cause an arithmetic exception. The try block contains the code that might throw an exception. The catch block handles the exception, preventing the program from crashing, and the program then continues after the exception is handled, allowing you to see the message and continue executing other code. So here we see we still get the printout of result 0, program continues after the exception, and then it prints out the exception details. We have division by 0, which is a problem. If you did not have this try catch block and we just tried dividing, we'll just get rid of this, the numerator by the denominator of 0, you can see it crashes immediately. We do not get any other messages because as soon as it gets to this line, numerator divided by denominator, it attempts to divide by 0, and that causes the system to crash. Okay, let's do another example. In this example, the try block contains two operations that can throw exceptions. Accessing an out-of-bounds index in an array, which can throw an array index out-of-bounds exception, and calling a method length on a null object, which can throw a null pointer exception. The first catch block catches array index out-of-bounds exception and provides a specific error message. The second catch block catches null pointer exception and handles it with a different error message. The program then continues to execute other code after the exceptions are handled. These examples demonstrate how to use try-catch blocks to manage exceptions gracefully in your Java programs, ensuring that the application can handle errors without crashing. So here we can see index is out of bounds. Program continues after handling multiple exceptions. Next, let's do an example of a finally block. It looks like I didn't close something. Let's see. There we go. Oh, okay. So in this, the try block attempts to open the file, example.txt, and read the first line. The catch block catches the file not found exception if the file does not exist and prints an error message. Finally block ensures that the scanner resource is closed, whether the file was successfully opened or an exception was thrown. This is important to prevent resource leaks like an open file handle. The output, the program prints the content of the first line if the file exists, handles any exceptions if the file is missing, and always closes the scanner to free up system resources. The finally block is useful because it guarantees that certain code will execute no matter what. This is especially important when working with resources like files, database connections, or network sockets that need to be released to prevent resource leaks. So even if the try block returns early due to a return statement, the finally block will still execute, ensuring that cleanup code runs as expected. And we can see that this ran even though the file was not found. Okay, let's do an example of throwing an exception. Okay, so the method set age checks if the provided age is negative. That would be this method. If it is, it throws an illegal argument exception with a descriptive error message. Throwing the exception, so the throw keyword is used to manually throw an illegal argument exception. And in the main method, the exception is caught and the error message is displayed. Caught exception, we see here. And then age cannot be -5. We can see that message is here. Okay, next let's do one more exception. Okay. So here we can see we set the score to 110 and it threw the exception. So this is a custom exception, invalid score exception. A custom exception class is created by extending the exception class, which we do up here. Method set score, which takes int score, checks if the score is outside the valid range 0 to 100. If it is, it throws an invalid score exception. Throwing the throw keyword is used to throw an instance of the custom invalid score exception. and we catch the exception in the main method, the custom exception is caught and the custom error message is displayed. Caught custom exception, score must be between 0 to 100, and then it shows the score is 110. Next, let's move on to array examples. So here we're declaring the array of integers and naming it numbers, and then we are initializing them. Okay, so first we'll go ahead and print each element in the array. And you can see it tells you at index 0, we have the number the number 5. At 1, 10 to 15, index 3 is 20, index 4 is 25. Now let's modify so at index 2 and the array numbers, we are going to update that to be 35, and then we will do a print statement. This \n is just a new line character. So here we can see again, we're printing out our for loop. The length of the array is being printed and we are getting the index of I and then each element at that index within the array numbers. After we modify it, we can see that the number at index 2 in our array is 35. So just to walk through this, the array declaration and initialization, that would be this line. This line declares and initializes the array of integers with 5 elements. The for loop iterates through the array using numbers I to access each element, and then modifying the array element, the line numbers 2 equals 35 modifies the third element of the array at index 2. And here you can see we print each element in the array fruits. So this line on line 3, this is our declaration and initialization. The string fruits, apple, banana, cherry, date, elderberry line declares and initializes an array of strings with 5 elements. And then our enhanced for loop, the for string fruit colon fruits. This loop iterates through each element in the fruits array, and this makes the code more concise compared to a traditional for loop. So we're creating a variable called fruit. This is string fruit. Think of it as in fruits, and then we're printing each individual fruit. All right, let's do an example of a multi-dimensional array now. So this is 2D array declaration and initialization here. This line declares and initializes the 3 by 3 matrix with 3 rows and 3 columns. And then we access the array elements in nested for loops that are used to iterate through each element in the 2D array. We access the element in the I row and the J column, and then we output the elements in the matrix. So this is a nested for loop. Let's do one more example. goodness. So in this, the line here declares and initializes a 3D array with 2 layers, 2 rows per layer, and 2 columns per row. And then down here we access the array elements with a triple nested for loop, which is used to iterate through each element in the 3D array. Cube ijk accesses the elements at the I layer, j row, and k column. And then we output the elements of the 3D array along with their indices. You can see here's the index and then the elements. Next, let's move on to a GUI example. So we do need to import for this. So here is our GUI. Simple GUI example, click me, and we can see in the console it tells us when the button was clicked, and then we can exit and it terminates. So JFrame is the main window of the application. JPanel is the container to hold the other components, so in this case the button. JButton is a button component with the label click me. The action listener handles button click events, so when the button is clicked, it prints a message to the console, as we can see. And set visible to true makes the window visible to the user. And when you run this code, the window appears with the button labeled click me, and when you click the button, a printout on the console says the button was clicked. Let's do one more example. We are going to just add to this. Well, no, I'll create a new one for clarity's sake. So we're going to make a basic calculator GUI here. Lots of imports for this. So to save time on imports, I'm just going to start writing this and then show you a way to import them all at once. So when it's read, show context actions, import class, and it does that for us. Okay, let's give it a try. Here you can see a basic calculator. Let's do 3 plus 2. Oh, let's try that again. 3. Uh-oh, we have a bug. Let's see. Let's try it again. Nope, still not quite right. What do we have wrong? There we go. Still some issues, but this is a basic calculator that you can create using Java Swing. And this is just an example of some of the GUIs, the user interfaces that you can create in Java. I don't expect you to create anything crazy with these. I'm going to try to come up with a fun project that's not super in-depth just to get your feet wet. But if you have any questions with anything that I demoed today, please feel free to reach out via email and we can set up a call to work through it together. I hope you have a great evening and I will talk to you next week.